In this illustrative access control scenario, a company approved a new policy revision that blocked high-risk exports unless a current owner authorization was present. The policy changed successfully in the central repository. Yet 23 AI agents kept an older cached revision and continued authorizing the previous path. Nothing had been hacked. The intended rule was correct, but the runtime decision was authorized by the wrong version. Policy integrity is a chain, not a document. A canonical rule must become a validated package, an approved revision, the active runtime policy, and a recorded decision that proves which rule was enforced. Break any link and a green policy dashboard can coexist with stale behavior. NIST Zero Trust Guidance centers access decisions on resources, subjects, and policy enforcement. OPA and Cedar documentation provides practical patterns for bundles, validation, testing, and decision evidence. These are design references, not a universal guarantee. First, map every decision point. Record the policy owner, decision service, enforcement point, affected tool, and failure mode. Define the principle, action, resource, and context each rule evaluates. Include background jobs, delegated tools, retries, regional runtimes, and emergency paths. If an action can bypass the mapped enforcement point, the policy is not yet a complete control. Second, validate the policy contract. Check types, actions, resource scopes, required attributes, and schema compatibility before release. Cedar validation can identify policies that do not conform to an application schema. Revalidate after every schema, tool, or resource model change. Reject unknown fields and impossible combinations instead of silently treating them as an allow condition. Third, test conflicts and boundaries. Define deny and allow precedents explicitly. Run positive, negative, boundary, and regression cases for each high-impact action. Test overlapping groups, missing context, expired approval, and contradictory rules. A bundle with no current tests, ambiguous precedents, or unexplained failures cannot advance. The author of the change should not be the only evaluator. Fourth, build and sign one immutable revision. Package policy and required data with a revision identifier, file hashes, owner approval, and a verifiable signature. Verify the signature before activation, then retain the last accepted bundle for rollback. OPA supports distributing policy and data as bundles and verifying signed bundles. A repository commit alone does not prove which artifact reached production. Fifth, distribute, then attest. Each policy decision and enforcement point reports its active revision, signature status, and health. Roll out through a canary before the fleet. Bar stale or unverified nodes from high-risk actions. Do not let availability pressure turn an unknown policy into permission. Promote only when the expected revision is active across the required scope. Sixth, log the rule actually used. Preserve a decision identifier, policy path, bundle revision, runtime identity, result, and masked context needed for review. OPA decision logs expose fields that can support this evidence trail. Alert on revision skew, missing attestations, or decisions without proof. Protect sensitive input while keeping enough evidence to reconstruct authorization. Now replay the illustration. The 23 stale agents are isolated before another export. The owner chooses a verified rollback or roll forward, finds every decision made under the old revision, and routes affected cases for re-review. Service returns only after the fleet attests to the accepted bundle and sampled decisions match the rule. That is the AI Agent Policy Integrity Autopilot: map, validate, test, sign, distribute, attest, enforce, and prove every decision.